But yes, let us do this one in here. So we have in here the graph of our cosecant function. So this is our cosecant function in here. I have graph in here one cycle or one period for cosecant. So as you may notice, one period looks like this one going up and one going down. And as you may notice in here, the period is this. The length from this one to that one, typically it's gonna be 2 pi, right? And that's gonna be the period. And again, that's the typical for a cosecant function, right? But definitely it's gonna change as you see your b value later, right? So what are the different key features on the equation of our cosecant function? They will be as such. Stretch factor, that's your a, right? That's how much it was stretched vertically. Okay, so as your a goes more than 1, then the more stretch that we're gonna see in here. Good, right? So we're gonna see, so if it's 1, typically this is 1 and -1, right? So the gap in here is also talking about the stretch factor as well, okay? Get it? Yeah. So whatever that is, that's your stretch factor. How much it was stretched from the x-axis typically, right? Or sometimes from the midline. Okay. Next one. The b value in here will determine how much your period is. Okay. So once again, the period can be written as 2 pi over whatever that multiplier for x is. So later we're gonna see how it's gonna affect our function. C is the phase shift, how much it has moved to the right, okay, to the right. If it's gonna be positive, again, you sign change whatever that C is. To the left, if it's negative, again, sign change whatever your C is. And lastly, your D, typically for sine and cosine, it's the midline. In here, you can say it's the midline as well, and that's the one that's gonna move it either up or down. Get it? So you can also say that it might be, you know, similar to what we can see as a midline for sine and cosine, simply because it cuts your graph into its upper and lower halves. You good? Anyway, let us consider this one in here. So as you may notice, this graph of a cosecant bx plus c plus d. So noticing in here, your a is 1, right? So as you may notice, the gap, okay, from here to here, from origin to this upper half, is 1, and the same in here, absolute value of 1. We good? So that's the distance, right? We also said in here our b is 1, so that means that one period is 2 pi. Now, how are we gonna see that one from this graph? So let's see in here. I'm gonna click under the graph settings. On the x-axis, we're started at 0 because there's no phase shift for this case, for example, and your period is 2 pi. Get it? And with this, since that is in terms of pi, we're gonna put our steps by pi as well. Get it? And as you may notice in here, your y-axis, you can change it from what again? I would say from, say, -10 to 10. That'll be fine, okay? For such, just to give you an idea on how it looks like. Get it, guys? Okay, so where's the midline? So the midline in here, or the vertical shift, is at y is equal to 0, right? That is your D. Yeah. See? This purple line splits your graph into upper half and lower half. Get it? Okay. What's your A? Your A is 1. So that's the what? The stretch factor. Very good, right? Thank you. That's correct. So as you may notice in here, from 0 to, what's that? 1. Get it? Okay. That's 1. Get it? Okay. Similar in here, from the midline to down, that's 1 as well, right? So the gap in there, from the midline to up and midline to down, that's your A, or stretch factor as well, okay? What else? Your scene here, well, we started at the y-axis, right? Or at x equals 0, that's why in here, your C, or phase shift, is 0. Good? Now, what if your C is something, let's say, pi over 2, right? Where will that go, right? So if you go to pi over 2, what happened? It went to the right, pi over 2 units. Well, actually to the left, pi over 2 units. Are we good, guys? All right. So for now, let's just change this one to big letter C. Good? All right. What else is necessary in here? Vertical asymptotes. Where do you think are the vertical asymptotes for this? Y-axis, right? So where is that y-axis in here? X is equal to 0, right? So that's one vertical asymptote. Where else?
Pi.
Well, midway between the period, so that's at pi. Very good, that's correct. X is equal to pi. And where else? The third one, where the period ends, 2 pi. Very good, right? So X is equal to 2 pi. Get it? So as you may notice in here, for a typical cosecant function, the vertical asymptotes happen at what? All the integral multiples of pi, right? 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, and so on. And their negative equivalents as well, or counterparts. Are we good? Now, let us, well, one last in here. What do you think is the domain and range for cosecant? For a typical cosecant function, we can say that the domain for this will be what? X will be what? All real numbers, except what? For the vertical asymptotes. Get it, guys? But for the typical vertical asymptotes for just cosecant x, it's just what? All real numbers except the what? K pi, or all multiples of pi. Get it, guys? Right. Next, range. What do you think is the range for this? So as you may notice, it was split into two, right? The lower half is what? From negative infinity to where? To 1, or in this case, A. Get it? Whatever your A is, negative of that, including that value, right? Also what? From the upper A, right? Upper stretch factor to positive infinity. Good, guys? So that's going to be our range for such, right? So let's see in here, where's the range? So for this case, we can put in here the following. For the range, we put what? Y is less than or equal to negative A. Get it? Okay. What else? The other part is what? Y is greater than or equal to positive A. Get it, guys? So whatever your A is, again, your A is dependent on that. So as you may notice in here, as your A goes more, your range and the gap actually, changes accordingly. Oops, changes accordingly as well. Are we good? Get it, guys? Good? Right. So again, your range for cosecant depends on A, or the stretch factor, right? Your domain, however, depends on what? Vertical asymptotes, right? All real numbers except where the vertical asymptotes are at. Questions? Questions, guys? Last one. Okay, let's notice this one in here, right? Going back in here. Okay. So this is the origin. What can you notice about this first half with regards to the other second half? Are they reflections along the y-axis, or can you say that this half is a 180-degree rotation of the other half? 180-degree rotation, right? So with that being said, as you may notice, this part in here, okay, if you rotate it 180 degrees, right, from the origin, right, it's gonna get the second half in there. And with that being said, what kind of function is cosecant? Is it odd or even? If it's a 180-degree rotation, it's odd, right? Good. So odd function when the first half is a what? It's kind of like an about turn, right? If you about turn, a 180-degree rotation is going to be the second half. Odd. So which means what? That f of negative x is equal to what? Negative f of x. Good. So for cosecant, we say what? Cosecant of what? Negative x is equal to what? Negative cosecant of x. Get it? Questions, guys, with it being an odd function? Okay. Questions regarding cosecant x? Okay. Now, let's consider solving a problem regarding cosecant x. All right, are we good with this? Let's see this problem. Okay, so here it is. Okay, laser range finder. Okay, let's read this one and analyze its key features, okay? Colleen, let's go ahead, number 56. Thank you.
A laser rangefinder is locked on a comet approaching Earth. The distance gx in kilometers of the comet after x days for x in the interval 0 to 30 days is given by g of x equals 250,000 CSC pi over 30 minutes.
Thank you. Okay, so we need to graph it. Find what's g of 5. Okay, and read the following items in there, right? So first of all, in this function in here, what is your a value? What's your a value for such? 250,000. Very good, right? So again, this is of the form y is equal to a cosecant b x plus c plus d, right? So your A, check, is 25,000, right? What's your B for such? B. Niste, what do you think is our B in here? The multiplier for x.
Oh, the B would be the pi 30.
Very good, right? This pi over 30 is your B. Oops, check. Very good, right? What's your C and D? Logan, what do you think about your C and D for such?
0.
Very good. They're both zeros, right? Get it? Okay, so in short, it starts at the y-axis, right? There's no movement left or right. And D, there's no movement up nor down as well, okay? But there's a vertical stretch and there's a period, right? So, first of all, how do we get the period for such? What do you do with that B to get the period? So we're going to use our triangle, right? 2 pi on top, B and P in here, right? So in short, to get the period, okay, what do we do? Paula, divide what?
You divide 2 pi by pi over 30.
Pi over 30. Ooh. So this is a little bit of a complex fraction. As you may notice, there's pi's up and down. Just cancel them, right? So what do you think is the period for such?
60.
60. Very good, right? So in short, one complete cycle, right, for cosecant is how much? 60. Also, that 250,000 is your what? Your stretch factor, right? That's the gap, right? From the x-axis to the top, right? So let's see, how does it look like? Okay, so here it is. I'm gonna graph it in here. Get the decimals and plug. Okay. Y is equal to, what's again? 250,000 cosecant. Did we say pi over 30? Right? X. Guys. So I'm gonna click on my graph settings. Get it? Change my x-axis. It says what? From 0 to, what's your period again? 60. Get it? And since that is 60, then your steps is by what? By tens or by ones, you know. We good? Right? Next, my y-axis, we said what? 250,000, right? So in short, we're gonna look for what? Y-axis that's beyond those two values, right? We good? So beyond 250,000, we can put in here what? Minus what? 1 million. So how many zeros are there? Okay. We good? Okay. In here on Y, I'm gonna do the same. Plus 1 million. Okay, so we're choosing a number that is beyond 250,000. Are we good? Right? So, you see it in there, guys, what we did? Once again, since our period is 60, that's our basis for the x-axis and our steps as well, right? Since our A a while ago is 250,000, then that will be our base for the y-axis, right? Something that is, you know, maybe double or quadruple of that A value, negative and positive. Get it, guys? Okay. Okay, now, let's see how it looks like. So here it is. Now, let's analyze this graph. Okay, so let's analyze this graph in here. Let me X this out. Once again, your midline is at the x-axis, right? Y equals 0. You don't have a phase shift. It didn't move left or right. Okay. A is 250,000. You see from this midline to there, that's 250,000. Right. Similar in here. Get it? Okay. Where else? B, that is 60, right? So from here to there, that's one entire period for cosecant is 60. Get it? Now, let's analyze some more questions or answer some more questions in here, right? Letter B. Let's read that one in here. Logan, let's read letter B.
Evaluate G of 5 and interpret the information.
Mm-hmm. So once again, your G is the distance of the comet after X days, right? So your X is in number of days, right? So when you say G5, that means what? On the 5th day, how far is it, this comet, from the Earth? Get it? Well, let's see. By the way, your distance is in what? Kilometers, right? Hopefully not near, right? Let's see. 5 days. Let's see. Oops, not this one, but this one, right? At X equals 5. Oh, thank God, right? Yeah. Right. Yeah. We don't wanna. What is that movie that has that? Is that a comet or like an asteroid or something, right? That hits the Earth.
Space Odyssey?
Huh? Space Odyssey. There's the song with Aerosmith. I forgot what that one is. Anyway, so as you may notice in here, after 5 days, it is how much? 500,000 kilometers away from the Earth, right? At what day will it be the nearest to the Earth? What do you think? At what day will it be the nearest to the Earth? On there. Somewhere in here, right? Let's see. What is that value where it's nearest the Earth? Ooh. On the 15th day, right? On the 15th day, it's nearest the Earth, which is how much? 250,000 kilometers away from the Earth's, hopefully, atmosphere. Are we good? Right? So hopefully it doesn't reach the, what layer of atmosphere is it?
Ozone.
Stratosphere, ozone, lithosphere, is that lithosphere or something? Ionosphere, right? Or something. Are we good? All right. Oh, what else? What else are the questions in there? Okay. Oh yeah, we have answered letter C, right? What is the minimum distance between the comet and the Earth, and when does this occur? What did we say again? Jalen? Yeah. After how many days? 15 days, right? On day 15, it is the nearest to the Earth at how much? 250,000 away. All right. Next one. Find and discuss the meaning of any vertical asymptotes. So where are the vertical asymptotes in here? Where do you notice are the vertical asymptotes in here? X equals 30. Very good. Where else? X equals 0, right? There we go. So in short, what can we say about 30 being an asymptote. What can we say about that one? How does it make sense from the function? Chase? What's happening to the distance of the comet after 30 days? So notice that's a vertical asymptote. So that means what? Approaching 30 days is how far is it? Infinitely far, right? Like too distant already. Like we can say like what? Light years away from hopefully, right? Light years away from the Earth, right? You know, by the way, do you know in physics what it means by a light year? Light year, right?
The amount of time light takes to travel.
In 1 year, right? Yes, the number of kilometers, of number of miles it will take light to travel in a year, right? So that's a light year. Woo. Hopefully light years away, right? Bye. Comment. Are we good? All right. Thank you, Jeremy. Any questions?